So as it turns out, 4.3 and 4.4 are very similar. Because we're just going over some postulates that allow you to prove triangle congruency. Okay? So I'm just going to give you those proofs, and then give you those postulates, and then we'll work some problems on the packet, then give you an opportunity to use those. All right? So postulate 19. Actually, I'm going to write all of these over here. 19, and I'm going to abbreviate this as SSS. Right? This is the side-side-side congruence postulate. So if you're looking for it in the book, that's what it's going to be named. But they also show you that the abbreviation is SSS. So if you're doing a proof for me, and you're writing down why you can, make the statement that you're making, SSS would be the reason for that. You don't have to write the whole thing out, postulate 19 or side, right? Just SSS means side. And so what this says is that if all sides are congruent, then triangles are congruent. So we have two triangles, right? And each of the corresponding sides are congruent, and the triangles themselves are congruent. And when I say the corresponding sides, I mean the length of those sides, right? Does that make sense to everybody? Mm-hmm. I'm so happy I'm going to eat a chicken nugget. So these are postulates to help you prove congruency. Anybody want to take a guess what SAS stands for?
Angle side.
Side and side.
Side, angle, side.
You're actually right.
I'm kind of giving you my abbreviated form of this. And you don't have to draw the picture if you don't need it, but it might be helpful. So if you have two sides that you know are congruent, and the angle between those two sides is also, if those two angles for each triangle are congruent with one another, then the triangles are congruent. Now make sure that you understand the meaning of the symbols, right, that we use. If there's a single tick mark here, then it means those two sides that both have the single are congruent, right? Here the double, that means these two sides are congruent. Here we have triple tick marks. I don't know if that's the official term, but that's what I call them. And so those two sides are congruent. And then of course with an angle, if there's just one curved line, each of the angles with one curved line are congruent, right? If there were two curved lines, then all the angles that had that would be congruent. Which brings us to our next postulate.
A lot of postulates.
And this is angle side angle. ASA.
Where is this?
Where?
Yeah.
4.3.
4.4.
Or 4. Oh.
We were in 4.3, we're now in 4.4.
Okay.
We're just cruising right along.
Yeah, because I didn't see it. Three. Error. Oh.
Yeah, I'm just gonna give you all of them, and then we're gonna use them. Two angles and a side between between them are congruent. Triangles are congruent. Right, so it's the same idea with all of these. Draw our triangles a little differently. So if you can prove that two angles and the side between those two angles are congruent for two separate triangles, then we know the triangles are congruent. And then finally, postulate. Nope, this one's actually a theorem. Theorem 4.5. Theorem 4.5 is angle, angle, side. And it says if two angles and a side not between them are congruent, triangles are congruent. So this one's like you have this, this, and then the side that's not in between the angles. It's also congruent. All right, any questions about those? About any of my strange symbols, what they mean? Or I wanted to write these concisely so that you guys can see how you can shrink them down and take up less space, right, when you're making your note cards. Yes?
Why is this one a theorem and the others are postulates?
Well, with the postulates, we've been able to definitely prove them. But with theorems, we don't have we haven't been able to prove every case. So all the cases we've tried are true. But they recognize with the theorems that there are other cases that haven't been tried. And so as far as we can tell, it's true.
Got it.
And we're going to treat it as if it's true. We're able to use those as proofs. Okay?
Got it.
Let me give you a few more things. I'm going to write those on the board. Theorem 4.6. We're now in section 4.6. The base angles theorem. And that says if two sides of triangle are congruent, then angles opposite are congruent. And so that means you have a triangle like this, and you know that these two sides, I'll let you finish writing that down. So if these two sides are congruent, then we can say that these two angles, the angles that are opposite those sides, are also congruent. And then theorem 4.7 is the converse of that. So it just states it the opposite way. If two angles of triangle are congruent, then sides opposite are congruent. So I mean, the diagram I'm going to draw would be exactly the same. It's just that with this one here, we're starting with the idea that the angles are the same. And so because we know that the angles are the same, then we can say, well, then that means that the sides opposite those angles are also going to have the same length. So we have a corollary to theorem 4.6, which says that if a triangle is equilateral, what does that mean?
It means all the sides are equal.
All the sides, the measurement of all the sides are the same, then that means all of the angles will also be the same. Okay, it's also angular. So I know some other people have talked, but I've lost track. So we're starting with a clean slate. Corollary. So there's a corollary also to theorem 4.7, which says the reverse. If a triangle is equiangular, then it's also equilateral. And so if we want to draw a picture of that, for both of those two, it would be basically this, right? All the angles are the same, all the sides are the same, and vice versa. So we put the brakes on. Good. All right, last one, theorem 4.8, and then we'll start working some problems. Theorem 4.8, this is the hypotenuse leg theorem. Hypotenuse, I'll just put that in parentheses so you guys know what that means. Since it's a little different from the others, hypotenuse leg. And so that says for a right triangle, if the hypotenuse and a leg of two triangles are the same, I should say are congruent, the triangles are congruent. So we have right triangles here. This only applies to right triangles, and if you've got right triangles, all it takes is this. One of the legs and the hypotenuse. The hypotenuse has to be, we have to know the hypotenuse is, in order to use this one, we have to know the hypotenuse is congruent. Sorry if I went too fast, we're about to slow down, work some problems. I just wanted to get all this on the board so then we can use this information. All right, so let's see if we can put these into practice, all right? And we're going to go, I already had one. With our study guide, we're going to go to problem number where is it?
Was it like the SSSS?
Yeah.
I feel like that's the last page.
Page 9, yeah. All right. Well, first of all, first we can start with page number 84. All right.
I had a question about homework.
Okay, David has a question about the homework.
So for 4.1 on 39.
4.1 problem 39.
Yeah, I was a little confused as to how to find the exterior end.
Anybody else confused on that one? Y'all quit trying to make David feel bad.
Wait, how to find it? The X.
4.1, page 39.
I would tell you, but I don't have my. It's one of those theorems where it's like the
Yeah, no, I know, it's the, if there's an exterior angle, the linear pair to that one, the other two equal that.
Right.
Right. Yep. So so what is the exterior angle?
For 39, we don't know the exterior angle, they just give us the interior angles.
Okay.
Or I guess the.
But we know this, that exterior angle is 180 minus x, right? So we can say that 180 minus x equals x plus 2x minus 21. Whoops,
I
21.
don't think we would put the x, I think we would just put 2x minus 21 equals plus 90. Is that?
Actually, that's all we have to do with this one. They put it on the exterior angle section, and this will give us the same thing. But we know that x plus 2x minus 21 has got to equal what? Is that what you were just saying, 90?
Yeah,
Right.
2x minus 21 plus 90 equals 180 minus x, I believe.
Well, what I was saying is because all of the interior angles of the triangle equal 180 degrees, and we know one of the angles is 90, then we know that 90 equals x plus 2x minus 21. So you see what I'm saying?
Yeah.
What you said I think would have worked, but actually, we don't even need to look at the exterior angle because all the interior angles have to equal 180. So 180 minus 90 plus one of the angles equals 90 is 90, and so all of those interior ones there have to equal 90. So 90 equals 3x minus 21, 111, right, equals 3x. And so 111 divided by 3 is what?
37.
37. Right?
Cool.
Got it?
Yeah.
Okay. Any other questions over the homework? All right, so let's see if we can use our theorems and postulates to do problems 84. Let's start with 84. So with 84, are the two triangles listed on number 84 congruent? So we've got triangles that look like this. We know that this is equal to this, and this is congruent with that. Can we prove that these are congruent?
Yeah. Wait.
With what postulate or theorem do you think you can prove that? What are our choices? Our choices are side, 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 angle, side, angle, 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 side, or if they were right, we could look at hypotenuse leg. Yes, Mary.
Side.
Mary says side, side, side. So these two are congruent, and these two are congruent. What's the third side that's congruent, Mary?
The one they share.
The one that they share, exactly. So don't forget, that one's got to be congruent with itself, right? So she's exactly right. Side, side, side proves that one's congruency. I should have done 3 there. I should have done this one. Was the other one, because we already had 3 on. Okay. What property is it that tells us that this is congruent to itself? Do you guys remember that? We learned it last week. Well, you know what? It actually, we learned it as it's related to triangles, but we've learned that property before as it's related to line segments and angles.
Chase.
The reflexive property, right? So when we learned it with, like if this was A and B, the reflexive property tells us that AB is congruent with AB. And remember how when we were learning that stuff, it was like, duh, why would we even learn that? What's the point? Well, it's because of problems like this, right? Now we see why when we're doing our proofs, like Mary said, this one's congruent to itself, it's equal to itself, right? That's the reflexive property that we would list as far as our reasons. Yes?
If Alice, if this question was on the test, we only have to put SSS or also.
You just have to put SSS, yeah. But Do I like to give partial credit? Yes, I do. So if you just put SSS, can I give any partial credit if you get it wrong? No, I can't. So if you could justify your answer, you stand a chance of at least getting another point or two. If I can just kind of see what you were thinking, right? So how would you do that? Well, I mean, you could like put the line here, maybe to just show me that you're recognizing that those two are equal. And that's why you say SSS. Or maybe write a little note over here, it's SSS because. So just keep that in mind, right? I'm always about giving partial credit if I can award you some of that, but you're going to have to give me more than just the answer, okay? And never ever leave it blank, because you definitely won't get any partial credit if you leave it blank, right? Okay. What about the next one? Oh no! No! Man, you guys don't tell the next class. You guys can't let them know that I did that. Okay, there we go. So let's just look at it together. Well, because of the people on the video, yes. You know what it is? Is that what or are you just having problems? You know what it is? Okay. All right, so I'm gonna go and put your name on the board, and I'm gonna assume that you can give me the correct answer. But let's see. Let me draw them real quick for everybody to see. All right, and we say this, this, and this. All right, what do you think, Cameron?
Angle, side, angle.
She says angle, side, angle. Does anybody disagree? And we've got two angles that we know are congruent, and we know that the side in between those angles are congruent, so she's exactly right. Angle, side, angle. All right. So you see why with 38 problems, was that what I said it was on the test? Some of these are going to go pretty fast, right? You're going to be able to just look at it. That's all it is. Just tell me real quick, 86, what's 86?
Angle, side, side. No, side, side.
Angle, angle.
If you had an angle side, side, but we don't have an angle side, side.
Angle, angle, side. Wait, no.
No, it's
You don't have an angle, angle side.
Sides.
Okay,
The hypotenuse leg.
hypotenuse leg.
Oh.
Exactly. You gotta look on this side, right? So we have the hypotenuse and the leg, we know are congruent.
Should we just abbreviate that one? HL?
HL, yep. Just abbreviate that as HL. 87. So this is an interesting one. So let me write this one on the board. So, wow.
That third, 4.6 and 7.
I didn't do that quite right, but anyway, this will still work for what we're trying to do. My diagram is not to scale, so don't look at that and go, they're clearly not congruent, Mr. Walker. There's a different side. But as far as what I've labeled on the drawing, how can we say that those are definitely congruent?
I think that's the theorem 4.6 and 7.
Theorem 4.6 and 7,
Maybe.
no.
Is it angle, angle, side?
It's angle, angle, side. Why?
Because there's two
What other-
sides that are congruent and.
Right? What are the two angles that are congruent? Obviously, these two are, but what are the other?
The center,
vertical angle.
the central one, the vertical angles, yeah, the center.
Right? These angles here are also congruent because of the vertical angles theorem, right? That we learned. Vertical angles are congruent with one another. So because of that, we can say that these are congruent, and so then angle, angle, side would be a reason why. So this is one of those scenarios that definitely, tell me why you thought that. If you told me that we can say that these angles are congruent based on the vertical angles theorem, then that's it. If you got it wrong, at least it would help I would be able to award some points and go, well, at least they knew what the vertical angles theorem was, right? All right, so let's move on to number 90. What additional information is required in order to know that the triangles are congruent?
The other two sides.
So if it's side, 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 what you would need to tell me for this one is H-I-G-K. 2, 2. All right. So if it's side, 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 what other information would I have
You
to
need
have?
at least one more side.
You need two more.
Well, I mean, two more.
I just
You need to be one on each triangle.
I know, like what Mary told us a minute ago, I know that this is congruent to itself. So what I really need to know is I need to know that HI, line segment HI is congruent with line segment IK. Do you guys see that? That's what we need to know in order to be able to use side, side, side. So this is what I'm expecting you to write on the test. Okay? Identify what additional information you need. If you want to write it out, but if you wrote it as simply as this, right, that would be sufficient. That's the additional info I need. This 91 is basically the same, right? What about 92?
You need to know the angle of measure, you need to know the measure of angle out, angle out.
Side angle side is what I want to use to prove that they're congruent. I've got that two sides are congruent. And I need to also know which two angles are congruent.
Angle KLM and VWX.
That's right. But since there's no chance of getting it confused, you could just say angle W
Okay, sweet.
is congruent with angle L, was it?
Yes.
Yeah.
Yeah, you can just say that. The only time you have to use all three is like in a situation like this, right? I can't just say angle. I'll wait till you guys get done writing. See right here, I could not say angle G for this because angle G could be either of these. So in that case, you'd have to do like you said, David, KGI. All right?
Got it.
Yes, Cameron.
What do you say for number 89? Because I feel like it could almost be like
Okay.
all the angles are congruent, but it doesn't say anything about sides.
Each side, so
89.
Yes.
Equal length.
They're both equal angles, so
would the
Should it be the
one be?
corollary
it'd be
Oh,
side
yeah,
and
yeah.
for
side.
part 7?
oh, yeah, we do
Corollary for part 7?
Yeah. I can
Yeah.
see it, right?
Yeah, it would be this one, two angles. Actually, it'd be this one, right? Two angles of a triangle are congruent. Don't we have two angles?
We have all angles.
Yeah, we have,
And so this is sufficient, right? Two angles of the triangle are congruent.
couldn't it also
Then the
be?
sides, well, the sides opposite are congruent. That wouldn't be just one.
Not equal angular.
That wouldn't be one. Yeah, well, equal angular means they're all the same,
Yeah, that's
right? Which number was that?
No.
This is gonna be funny on the video because my face is gonna be like right in the video now. Which number?
Number 89.
89.
Can that be corollary to theorem? Well, because it's not equal angular, so look at the.
Oh, it's not equal, yeah, you're right.
Ah,
Angular.
guess what the answer to that one is?
Angles aren't.
Not enough info.
Interesting.
NEI or NA.
Not enough info yet. We're gonna learn in the future that we actually do have enough info to say, but yeah, for what we know so far, we don't have any theorems or postulates that would make it possible for us to prove
Right,
that those are congruent, okay?
I mean,
All right. So any questions about anything else before we move on and work some other problems? There's-
Not
Huh?
enough info yet, would that be on the test, like some you can't answer like that?
Yes. Yeah. The Determine if two triangles are congruent. If they are, state how you know. So the statement says they may not be, right? If they are, tell us how you know it. If you don't know it, then just say none of that. Okay, there's a bunch of problems on the back, sheet 2, 93 through 101. Do you guys want me to work any of those? Because I want to go over, I want to do the proof packet, but I'm going to have to display that on TV. Yeah, this is going to get really messy for, for the video. Yeah, I am still charging. I'm just curious. Let's see. What are we up to? We're up to 4%. Oh yeah. Oh yeah. I'm dying in 2 seconds. All right. So, any questions about those? Like I said, I've sent you guys the answers, but if you look at one, you're like, oh, that one will be. Those are pretty straightforward, I feel like. What about 101? I did it backwards.
You need to know.
You need to know.
You need to know side
Angle,
GF
side
and
angle.
GV
So it's
and
not
angle
enough
F and V.
information.
No, it's saying what, it's stating what.
What do I need in order to do it? So let's just
Wait,
don't pay attention to your packet, but look at the drawing that I drew to see if you can tell me if I'm trying to use angle side angle, what else do I have to know is congruent in order to use angle side angle?
The measure of G and V and G and F.
Yeah.
These
For the
two?
sides. For the
Yeah.
sides.
Oh,
Side
this?
angle.
But no. We already got an angle that we know is, we already got a side that we know is equal. We got an A and an S, right? This is our A's, and this line here is a side that's equal.
Okay,
So what we need to know that these two,
got it.
right? So the angle, we need to know that angle VHF is congruent with angle
It's not side angle, side.
GHF. It's angle side angle,
Angle, side angle.
right? So you pay attention to what this says here so that you know which one to give you. All right? So for this one, it should actually be GHF.
Oh, wait.
Yeah, it's different for the problem. It'll be GHF and GHV have to be congruent. Or VHG and FHG, however you want to write that. Okay? All right, so let's see if we can put the proof. And so I'm just going to send you guys, I'm going to email you guys the proof packet. Should have already done that. Should have done that when I sent you the other things that we all be in one email, but I forgot. I have to be very careful because I just realized I've got the test up here in Adobe PDF, and I don't want you guys to accidentally see that. That would be bad for everybody, right? So bad. All right, so the proof packet, here it is. Here's a proof packet. All right, so let's think about this for a second. And let's do a couple of these. And like I said, I'm going to send you the whole packet so you can jingle bells, jingle. We have to sing that every time I bump those accidentally. Okay. So for this one here, we're given that here. Let's see if I can do this. Let's try to not show you the answers. There we go. All right. So we're given BC is congruent with DC, and then
AC is congruent to EC.
AC is congruent to EC, and we're trying to prove
Triangle BCA is congruent to triangle DCE.
which one? DCE?
Yes.
Okay. All right. And so we've got a drawing that looks like this. and it goes down like this, and then this goes like this, and this goes like this. And we've got A, B, C, A, B, C, D, E. And we know these are the same. Actually, I don't know if that's initially given. Let me see. It looks like it's, I can't tell. I think that's been drawn on there. So I think this is all that was given. Actually, this, and this. Okay? Yeah, because that's all that was given. BC and DC, right? BC and DC are congruent, and AC and EC are congruent. And so we're trying to prove that the triangles are congruent. All right. So we've got our statements, right? And we've got our reasons. So if I was going to do this whole thing from scratch, and what you'll have on the test will not be all from scratch. I'm just going to leave some blanks and let you fill those in. Okay, for your proof. Statement one, we always list at least one of the givens at the beginning here, and we're just going to go ahead and list both. So we're given that BC, it is coming down. I did not bring my umbrella or my charger. So given for that. What else am I going to need to prove these things are congruent? What theorem do you think, or postulate should I use to try to prove that these are congruent?
Try to use the side angle side theorem.
Side angle side. I agree. Postulate 20. All right. But in order to do that, I've got to prove that these two angles are congruent. Vertical angles theorem. So number 2. So I'm going to say that angle ACB is congruent to angle DCE, and that's because of vertical angles. Here.
Put 3 instead of 2.
Oh, thanks. I do that. I don't know why I do that. I'm just going in order, you know?
Yeah.
So that tells us, that's why this was drawn on the paper. That tells us that those are congruent. Now we can say, we can have our final statement, angle BCA is congruent with angle DCE because of side angle side, right? So see how easy that is? Did you guys do that?
Oh, yeah.
All right, let's see if we can do one that's a little bit harder. Let me remove this so you guys can't see it. There's my face really big on the video again. They're loving it.
Oh, yeah.
Hopefully they're looking at the top of my head. Let's just see. I'm curious. They are. Yep. It's just like from here up. It's awesome. Did somebody say that's funny? You're saying that I look funny from here up? That somebody just said that. I heard it.
The fact that
All right. Let's see. Okay, here's an interesting one. All right, I'm going to just draw this instead of putting it up there and see if you guys can tell me what the missing pieces are. Jingle bells, jingle all the way. All right, so we're going to draw this. We're going to draw this, and we're going to say these are right. So N and Q are right angles. NO and PQ, and we're also going to say that these sides are congruent. All right, so this is what we're given. We're given the following, that angle N and angle Q are right angles, and that line segment ON is congruent to line segment QP. And we're prove that triangle ONP is congruent congruent with PQO, triangle PQO. All right. So, got our statements. Got our reasons. Number one, we're going to list our givens. I'm not going to rewrite all that down. Okay? So you guys can just look at those right there. But on a test, I would expect you to if that was blank, right? How are we going to try to tackle this? To prove that these are congruent.
Use the side angle side theorem.
So the side angle side. So you want to prove that this side and this side is congruent. Is that what you want to do? Anybody want to take a different approach?
Use the
Hypotenuse leg. I'm kind of thinking that would be the simplest way to do it because we've already got a leg. We know the right triangles. We've already got legs that we know are congruent. So all we've got to prove is the hypotenuse are congruent.
And yeah, just do the same thing.
So we could actually just say that we could say that OP is congruent to OP.
Because of the reflexatory.
Not reflexatory, but just the reflexive.
That one.
That's the one, reflexive property. If you said reflexatory, I would snicker while I was grading it, but I would still give you credit for it. All right. And then finally, do we have enough information?
Yeah.
We can actually go straight now to our final statement, right?
Which is that,
What's our proof? What's our reason?
the
Hypotenuse.
So just HL, right? We actually did it faster than they did it in the example here. Oh, okay. Yeah. Forgot one small detail. And that is this. What is the definition? What does the hypotenuse leg theorem say? It is a right triangle, but we weren't explicitly told that. So what they did is they had a little, so we're gonna do right here.
Well, it does, what is it given?
No, it says that those angles are given, but we have to prove that that means it's a right triangle.
Yeah, so we're gonna do step 1A right here.
That's stupid.
1A, all right? And so, yes, because of the definition saying that, again, nothing's understood, you sort of have to prove everything. But we say that that angles, the triangles ONP and triangle PQO are right triangles. And that's based on the definition of a right triangle. All right, so that's technically true. If you left that step off, I would just count off a point for that, right? Because it's just easy for our minds to sort of jump to that, but it does point out the fact that we can't assume anything is understood, right? We have to explicitly prove it. And since the theorem doesn't say if each of the two triangles has a right angle, it says if each of the triangles are right triangles, right? So we proved that they're right triangles by using the definition of a right triangle. Does that make sense to everybody? Sort of, kind of? You see what I had to do? I had to say because I can't just say they're right triangles. The definition says they have to be right triangles. I have to say they are right triangles because they both have right angles. So that's why that step is necessary. So that one would be in there.
Oh, okay.
Makes sense now?
Yeah.
All right. So I'm going to send you the proof packet so you guys can look through that. What time do we get done here? In 15 minutes?
Yeah.
Okay. So what I want to do is for the rest of the class is just let you glance over the worksheet, the study guide, and see if there are any problems that you want me to go over. Something that you want me to do.
I don't know that.
You know, obviously you need to know all the different types of angles. Like is listed in on the first page there. We've seen that before. We've had that on a previous quiz. Jingle bells, jingle bells. Okay, let's see. Page number 2. And notice there's all kind of funky ways that I could draw those angles. You guys see that? Like if you look at number 12, there's all kind of lines on there, right? But we really don't care about all that other stuff. We really just care about the fact that there's something that looks like this, right? And you've got, you know, an angle here and here. So don't let all the excess stuff throw you off, right? We're just focused on that. And what kind of angles are those? Alternate interior angles, right? So we can find the measure of the angles based on what we know with our various theorems. Anything that you want me to go over?
So basically, for 27, 28, 29, 30, and whatnot, it's telling us just basically to find the angle. So we can just take out that U and V parallel, which is extra.
Find the value of x that makes the lines U and V parallel.
Yeah.
Right, so if we assume that they're parallel, then like 23 through 26 and 21 and 22, they list that those lines are parallel. So because those lines are parallel, we know there are certain relationships that are valid between those angles, right?
Mm-hmm.
So for example, number 27, right? 27 is the same as 21, but 21 we're told the lines are parallel. And so for 20, what do we know about two parallel lines and alternate exterior angles?
They're equal.
They're equal.
They're equal.
Technically vertical.
Yeah.
All right, so if they're equal, then what would the question mark have to be on 27 in order for
110.
it would have to be equal, right? It'd have to be 110 as well. Does everybody see that?
Yeah.
We're just putting in the value that makes it parallel. And so same thing for 29. What's the value of x that would make those parallel? Well, those are what are those angles called?
Those are corresponding angles. They equal each other.
They're also equal to one another. Those lines are parallel. So we would say for that one, we would say, okay, then 13x plus 8 has to equal 12x plus 17, right? And then we would solve that guy, get all of our x terms on one side. So we move this 12x over here, and we move the 8 over here. So it becomes 13x minus 12x equals 17 minus 8. So x equals 9. So that's the value that makes those parallel. Slope-intercept form, I just gave you guys back a quiz on that. Some of you did have some issues with the quiz, so I think I went over that quiz last week in class. No?
Are you gonna give us the quiz back from last week?
Did I not give it to you? Oh,
No.
Or the one before?
sorry, yeah, they're right here.
Wait a minute.
Good, because I didn't want this to get really fat. I didn't want to take it home again, accidentally. Gotta need to review this, but I haven't figured it out yet. So some of you have still got to type 2 tests. That's like I normally do this problem by working out on the test usually. How was this? Smells like cookies over here. Is that somebody's drink or perfume or something? It smells wonderful. Making me really hungry. No. Okay, are you still listening to work? You guys are still listening to one more quiz. All right, last one. Guys, why don't we ever do this again? It's too long. Maybe about 2 weeks worth of work.
Oh, you didn't do a
Okay, is anybody expecting work back that has not received it? All right, so we have just a few more minutes. Any questions? Yes, Kylie.
Could you do 48 on the study guide?
On the study guide, yep.
Just talking.
48. So 48 says find the value of x. Okay, so this is this that we use to find that, right? So if the side opposite two angles that are congruent, the sides have to be congruent as well. So 48 would just be 4. Make sense?
Yeah.
Right? So I'm glad you pointed that out though, because I didn't realize that's some more stuff that's used in the new theorems and postulates that I hadn't gone over yet. So same thing for number 49, right? X would be 8 for that. What about 50? So 50, we have 48. 48 degrees, this, and we're asked to find x.
So that'd be 48 plus 180 minus, and then, so that'd be.
Yeah, so this is not 48, right?
So it'd be,
According to theorem 4.6, this is 48.
yeah, so it'd be 180 minus.
So it'd be 180 minus 48 minus 180 minus 48
6.
minus 48. That x equals that, right? So yeah, 90. What'd you say, 76? No?
106.
96?
Or it'd be minus 106, which would be 74.
74?
I think so.
I think you're right. 74. All right. So any questions about any of those? Any other ones? So 5 more minutes, so if something's jumping out at you.
I just typed that into my calculator.
It's not right? 84?
Oh.
Okay. So 84, yeah, that's right, 84. Anything else?
Which question was that?
That was question 50.
So 51 would be like the same thing.
51 would be 50. X would be 50. Yeah, because those sides, those are angles opposite the congruent sides, right?
Oh, it's an X, okay, that makes sense.
What about 52?
52.
It tells us the measure of angle 2 equals 50 plus x. So we're trying to find x. So what's the measure of angle 2?
So 42
So that's what we write down. We write down 42
equals
50 plus x. So x in this case equals -8. So I'm glad I did that one. Don't let that throw you. X is not a length, so it's okay if it's negative. X is just an equation that they gave us.
Oh.
So for that one, x is -8, right? Anything else you guys want to try? Let me get in front of the camera again. Anybody at home? No? Okay. All right, well, you're good.